All right, in this first unit of section of Unit 5, we're going to be talking about exponent rules review. And what we're going to really be talking about is combining like terms. Now, we've combined like terms all year long, so this is nothing new exactly, but it is maybe with a little bit more of a difficult twist. When we're talking about combining like terms, then we're talking about the variable parts have to be exactly the same, including their exponents. We already know that we can only add x's with x's and y's with y's and numbers with numbers. But that's now going to carry over as we start working with exponents, that you can only add and subtract terms that are exactly the same in terms of their variables. So long story short, look at part A. And the like terms are the ones that are exactly the same. So that would be they have an AB and this has an AB. So those are what's known as like terms. The numbers are different, but the variable portions are the same. And then I look at the other two, and it looks like I have an A squared B and I have an A squared B. The last one here, AB squared, is different. So it matters which one the exponent's connected to. It has to be exactly the same. And the way I like to think about these is I think of them as objects. So I think of this as an object named AB. So this is just basically telling you have 4 of those objects. And then if I have minus 6 of those objects, if I combine those together, 4 minus 6, of course, is negative 2 of those objects. So those two terms would combine together. And then I have a new object called an A squared B, and I have another one, A squared B. So you have 3 of them, I have 5 of them. When I add them together, we have 8 of these A squared B's. And then I have no like terms, so this one just is by itself. So that's how I would identify and combine like terms together. So I go to part B, and again, it looks very confusing, and so that's why we just have to pay attention. I have C squared D squared. Not the same, not the same, C squared D squared. So these two are the same and can be combined together. This is a CD squared, this is a CD cubed, this is a CD cubed. So the D cubed, CD cubes can be combined together. And just like the last time, we have one guy standing out by himself. And so now I just do what it says. I have 10 of these and 5 of those. So altogether we have 15 of them. And I have negative 3 of these and negative 4 of those. So that's a total of negative 7 of those. CD cubes. And then I've got my 6 CD squareds all by themselves. All right, last one. H to the 4th J. Not the same, not the same, is the same. H4J squared, not the same, not the same. So that guy is all by himself. H squared J squared, nothing else like that. And obviously we have H cubed J squared all by himself. So the only two that I can combine together are these, the first and the fourth one. So that's going to give me 17 of those. And then all the others are just as they are written. So that doesn't change. This one doesn't change. And this one does not change. So this is pretty simple. The area that we're going to make a mistake on is either A, writing the problem down incorrectly, or possibly just not focusing on what the exponents are specifically connected to. So we just can't force things together that don't belong, and that's it. All right, example 2. Now we're looking at these in one big long string, like what's known as a polynomial, which we'll study in a whole chapter on its own. So we have a string of terms added and subtracted together. This is not unlike what we've done earlier in the year. And now before we go any further, we just want to combine like terms. So when you write these down, I encourage you to be very methodical. Make sure you double check that you didn't skip any, because that's honestly going to be probably your biggest error, is just writing them down wrong. And then remember that anytime I do something with a term, like for example, if I'm going to do something with this 6a term, I need to know that this negative belongs to that 6a, right? And so we have to pay attention to that as we're going through our work. All right. So lots of ways to do this. I think the most logical way would be just to go through and identify the ones that are the same. So I'm going to start. I'm going to see if there's any more a cubes out there. And I see this one, and I'm going to make sure to pay attention to the negative of it as well. And I keep going. We're doing what? A cubed. It lost focus. So those are my only two a cubes. So I might as well do those right now. 5 minus 8 is negative 3a cubes. And then what I would like to do is I'm going to just kind of cross them out. That way I make sure I get everything accounted for. I think I'm going to go find my next highest variable, which would be the a squared. So I'm going to focus on the positive, right? The plus belongs to that. A squared. There's a plus some a squareds, and that's it. So I have positive 7 plus 5, so that's going to be positive 12 a squareds. I cross those out. And then I'm going to do my a's. So I have minus 6a minus 3a plus 11a. So write it down if you need to, but essentially I've got negative 6 minus 3 is negative 9, and then plus 11. So negative 9 plus 11 is positive 2, so I have positive 2a. Cancel, cancel, cancel. And then the last two I have, and again, pay attention to the negative of it, negative 12 plus 4, and that, of course, is going to be minus 8. And then we have checked everything off. We haven't missed anything. All right, so let's do the next one. Pause the video, write the problem down, try it yourself, and then check back in. So I'm going to start. I have x squared y's. I have, nope, yep. Keep looking, x, no more. So those are the only ones. So might as well do them while I'm here. So 3 of them plus 2 of them would be 5x squared y's. The object doesn't change as I add them together. They're still x squared y's. All right, really doesn't matter which ones we do next. I'll focus on xy's. So I have negative 16xy's. And now I have minus 13 more. And then I have plus 2 of them. And that's it. So negative 16 minus 13 is going to be negative 29. Plus 2 should be minus 27 of them. Positive 5xy squareds. Here's some more xy squareds. Here's some more xy squareds. So I'm going to add all those together. 5 plus 4 is 9, plus 11 is 20. And then, unless I've made a mistake, I've only got one of these. I'm just checking back. I don't have any x cubed things anywhere. So yeah, that's just a standalone. So plus x cubed y. And I think I got them all. All right, if you are good, I would say go ahead and turn the video off and go ahead and start your assignment. Otherwise, I'm going to do, I don't know, a handful of these. I'm not going to do them all. Maybe I'll do like A and E or something. So part A, let's see, I've got some h squareds and some h squareds. So 2 plus 2 is 4 of those. I've got a minus 7h, a minus h. That's what? We're at negative 8. Plus 4 is negative 4. Minus 9. I've lost track, so I'm going to start over. And you can add these together in any order. Just make sure you pay attention to the signs. So, for example, if I want to do all the negatives first, negative 7 minus 1 is negative 8. Minus 9 is negative 17 h's. And I'm going to add 4 h's back. So that would be, I think, negative 13h. So we've taken care of everything but the plus 6. So we also have a plus 6. All right, I think everybody gets the idea. Let's jump down and do part E simply because I want to talk about the parentheses. This one has parentheses, but I want you to notice that we're adding. So this is like distributing a positive 1. And what happens when you multiply by a positive 1? absolutely nothing, right? So these parentheses you could basically say are for show. It's kind of like pretend for a second, maybe this came from a triangle, and each one of these parentheses is like how long each side is, right? So this would be the 3x squared one, and this would be the 6x squared one, and this would be the 9x squared one. And I said, hey, what's the perimeter? Then you would add them together. And so how would you add them together? You would add 1 plus 2 plus 3. You would add them all together, and it might look something like this. Okay, my little clicker's not working. So we have them all strung together. And so the parentheses are there just to sort of organize, like, oh, look, this part right here is just one of the sides. And this part is one of the sides, right? This is just trying to like give you an example of why one might have written it with parentheses. But in reality, because it's all addition, like we said before, distributing a plus does nothing. So this is really basically what I'm saying is you can take the parentheses and throw them away. If it was a subtraction, you would not be able to do that, right? You would have to distribute the negative. All right, so let's just go through and find the like ones. So 3x squared, 6x squared, 9x squared. So 3 plus 6 is 9, plus 9 is 18. I have 18x squareds. Next, let's do the xy's. So I have positive 2 of them, minus 5 of them, and that's it. So that's going to be negative 3 of them. And then everything else is a y squared. So this will be 4 of them, 7 total, minus 25. So 7 minus 25 is going to be, let's see, take away 5 to get to 20, and then 2 more left. So that would be negative 18 y squared. All right. Hopefully you're all set and ready to go and everything seems easy. Go ahead and get your assignment done, and we'll see you in the next one.